Europa.
Galileo could see them through his telescope, you can see them through yours. Your
Your
telescope is better than Galileo's.
That's true.
This is a particle podcast. WA Science told different. Powered by Scitech.
Good evening, everybody. My name is Leon,
And I'm Beth.
and welcome to Please Look Up, your monthly deep dive into space news,
And commentary.
recorded at Scitech on Whadjuk Noongar land.
So, Leon, what's up this month?
Excellent question, as always, Beth. Yes, we're looking at the night sky in December in Perth.
Yes.
And it's an interesting one because we're coming into summer now. December brings us into summer. And what that means is the Milky Way, and as marked by the Southern Cross as a reference point, is very low on the horizon.
Disappointment.
Yeah, it's very low. In fact, the Southern Cross, depending on where you live, may actually be partially below the southern horizon.
Yeah.
So what this does mean is it gives us an opportunity to look for some of the lesser well-known constellations that are out there.
Yeah. So we're going to start out facing south just after sunset.
Yes, that's right.
Amazing.
So as we always say, you look where the sun has just set, and that is west,
Yep.
and then you turn to your left, and now you are facing south.
Now you're facing south. So what am I looking for in the southern sky?
Well, I guess you might want to start with looking for half of the Southern Cross.
A bit of it.
Yeah, it's the long arm sort of sticking out of the ground is what you'll see there. But towards the higher up in the sky, slightly is towards the southwest. There are 4 constellations. They are very faint, but they're all grouped together, and they're called the Southern Birds.
Are they actually birds?
They are, as a matter of fact.
Okay. Because you know what I mean? Quite often you see a constellation, it looks like something, it looks, maybe it's not what it actually is meant to be. And I am also pretty sure that out of the southern birds, one of them, correct me if I'm wrong, is Parvo,
That's correct.
which is a peacock.
Yes, that's right.
It looks like a whale.
It does. So, as with all constellations, the lines you draw between the stars and then the picture that somebody else has glued over the top of it usually don't look actually that similar.
Is
But
Phoenix also one of the southern birds?
Phoenix is one of the southern birds.
Because that one looks like a coat hanger.
Yeah, it does too.
Yeah.
Now, if you're wondering how we're seeing this, to be fair, these are quite faint constellations. So my suggestion would be to perhaps look them up online beforehand so you can sort of get an idea of what you're looking for. Or when you go outside with your favourite app,
Stellarium!
yes, fire up Stellarium on your phone or on a computer, and you can get an idea of what sort of stars you're looking for to see these. So yes, there is Parvo and Phoenix. And then there is also Grus, which is a crane.
Oh.
And there is Tucana, which is fairly self-descriptive, I'd like to say.
A toucan?
A toucan, that's
Yay.
right. So yeah, there are these 4 constellations in the far southern sky, and in the southwest during December, and they're called the Southern Birds because they all have that thing in common. They're all birds.
Yeah. Even though they maybe don't look like birds.
They maybe don't look like birds, but that's okay. So that's a good place to start.
Now, I don't know a whole lot about the southern birds, being someone who grew up in the northern hemisphere. The southern birds, most of them are too far south to really get a good view of, but there is a very famous constellation in the sort of northeast at this time of year, which is across both hemispheres, is very famous. But my Australian jokes finally work because this one is upside down.
It is too.
It's Orion.
Yes,
The famous
that's right.
3 stars in the belt. I know that they're up in the east at the moment, so if we've just been looking south at our southern birds, keep turning left.
Turn to the left.
Yeah. And still relatively soon after sunset you can start to see Orion.
Yes, that's right. Yeah, Orion is sort of at that stage where it's rising as the sun sets. So it's only going to get better as the month goes on.
Yeah.
But you don't have to wait too long.
Yeah. So Orion I find quite funny because I always knew you find Orion by the belt and then one of his shoulders is red and his foot is blue.
Yes.
And it's a really fun constellation to go out and spot, partly because it's so obvious, and also I think that it does actually look like a human being holding a shield or a bow.
It does.
It
yes.
actually does look like what it's meant to, but also Taurus is very nearby. If you have a couple months ago now was our constellation of the month.
Yes, that's right.
Very easy to spot in the evening sky if you missed it a few months ago because it was up too late, right next to Orion. But yeah, here I say his shoulder is red and his foot is blue, but he's upside down here. So it does kind of look like it's his foot that's red.
Looks like his foot that's red.
Yeah.
Yeah, that's right. So yes, if you are looking at star charts of Orion, be prepared that he is upside down in our sky.
Yeah.
But you get used to it once you're used to it. And the easiest part to spot is, of course, those 3 stars that make up Orion's belt.
Yeah.
And then yes, as Beth said, Taurus is slightly further to the north. In other words, you keep spinning left.
Keep turning left.
And Taurus, you're looking for like a pointed arrow or a V shape of stars, and those are the horns of Taurus the bull. And we did discuss Taurus a couple of months ago.
Yeah, and at the moment, very near Taurus is actually a planet.
That's right. So yes, in between Orion and Taurus, and technically it's inside the constellation of Taurus, there is a very, very, very bright object there. You can't miss it, and that is the largest planet in the solar system.
Pluto. No. Very much Jupiter.
Oh boy.
I'm about to get fired from the planetary.
You keep talking like a fool.
Jupiter. It's so yellow.
Yes, it's very, very bright in the sky. It stands out, almost whitish sometimes, depending on the how much what the atmosphere is doing. And yes, it's rising almost just after the sun sets. So yes, you'll be able to see that 8 o'clock at night, 9 o'clock at night. Just the sunset. Orion's there, Taurus is there, Jupiter's there.
I actually had someone ask me that the other day. I saw a really bright star, like just after sunset. I couldn't see any other stars. It was over in the east, and I was like, probably not a star. It's probably Jupiter. Although it could be kind of confusing at this time of year because Sirius is also in the east, and Sirius is the brightest star in the night sky.
Yep.
But I've got a little trick. So
Okay.
Orion's belt, those 3 stars, if you draw a line through them, sort of down towards the horizon, and you'll come across a very bright star, that is Sirius.
Right.
Whereas at the moment, Jupiter is if you've got those 3 stars in a line, but instead of following the line down,
You follow it up.
you follow it perpendicular.
Oh, right, perpendicular.
Yeah.
Gotcha.
So perpendicular at the moment, and then obviously it depends on what time you're spotting it as well. It will eventually be
It'll eventually be.
the other way round. But yeah, down towards the horizon, through the line of Orion's belt will be Sirius. If there's another bright thing on the other side of the belt, that's probably Jupiter.
Gotcha. So to paint a picture of the eastern sky, we're looking outside and we're seeing the 3 stars of Orion's belt. They're in the east, and then slightly to our left,
Yep.
there is the V-shaped pattern of stars that makes up Taurus.
Yep.
Going back to the belt, we're going to look essentially halfway between the belt and Taurus, almost perpendicular. There's Jupiter. Going back to the belt again, we draw a line from the belt through the belt to the right-hand side to the horizon, and there is Sirius,
Yeah.
which is a star. It is the brightest star in the nighttime sky.
It is a star. So brightest star in the night sky. If there's something brighter, it's probably a planet. You can just about see Canopus as well at this time of year, which is the second brightest star, which is further south again, so further to your right than Sirius. And it is the brightest star in the sky, but also, of course, in the constellation it's in, which is Canis Major, or the Big Dog.
Yes. Oh, sorry, I see what you mean.
Yeah.
Yes, gotcha. And that does lead to a fun little fact that I've always liked about Sirius, which was you're like everybody who is a fan of Harry Potter is aware of the character Sirius, Sirius Black, and at the start of Harry Potter and the Prisoner of Azkaban, Sirius Black has escaped from prison. We don't know what he's up to. Meanwhile, Harry Potter's being followed by a big scary black dog, and then of course the plot twist at the end of the book is that
Spoilers.
Sirius Black, it turns out to be the black dog.
Yeah.
And I'm like, what plot twist though? Wasn't that obvious? Because Sirius is in the dog constellation. It's Sirius
And it's also
Black.
the dog star.
Yeah, it means black dog.
Sirius Black means black dog. Yeah, but then you've also got Remus Lupin, which is basically Wolf, and that's
true.
another plot twist in the same book.
Yeah, I guess so.
Some might call it Latin that goes above the heads of small children, but is a nice little nudge to nerds and grown-ups.
There we go. Now, speaking of planets, you've got Jupiter in the eastern sky after sunset. Now, we can't forget to mention, of course, in the western sky after sunset.
Oh, here we go again.
It's been there for a few months.
Third month in a row.
Yeah, it's going to be there for another couple of months. We are, of course, talking about Venus.
It's Venus again.
Now, throughout December, Venus gets to its sort of highest point away above the horizon.
Okay.
So it's up to almost about 10 o'clock at night now. So it's never going to be up all night, but depending on where Venus is up to in its orbit and so on, sometimes it sets 7 o'clock, 8 o'clock, 9 o'clock, and by the end of December it'll be setting almost at 10 o'clock at night, which is very, very, very late. So yeah, make sure you check out Venus. Mercury is not really trying this month.
No.
It's lost behind the sun. Saturn is still there in the northwest, just after sunset.
Yeah.
It's kind of fading and pale now, but it is there in the northwest. But it's going to be, you kind of need to really concentrate to spot it.
But it does mean that just after sunset, if you go out, you can actually spot 3 planets in the night sky, which I think is quite fun.
That is quite cool.
Yeah, so you can see Venus, Saturn, and Jupiter.
Yep. Sorry, going back to Jupiter.
Yes.
Jupiter is about to reach what we call opposition, which is it's opposite the sun in the sky.
That's the one where if I hold my arms out and point to the sun, then Jupiter will be at the other side of my arms.
That's right, yeah. One hand will point to the sun and one hand will point to Jupiter on opposite sides of the sky. And that happens on the 8th of December. So the instant the sun sets on the 8th of December is the same instant that Jupiter rises. And so that's why it's called opposition. And so that means it's actually the best time for the next 12 months to look at Jupiter, because we're looking at it face on. So we're seeing the fully illuminated face of Jupiter.
So that's why it looks so bright in the nighttime sky.
That's right, yes. We're seeing it face on. And not only that, if you think about the geometry of where Earth is in all of this, we're about as close as we're going to get to Jupiter for the next 12 months as well.
Yeah.
So, yeah, worth looking at.
Absolutely. And also, if you've got a small telescope at home, you might be able to spot those sweet moons, the big ones.
The sweet moons of the Galilean moons, as they're called.
Yeah.
Yeah, you can easily see those through a telescope.
If Galileo could see them through his telescope, you can see them through yours. Your
right.
telescope is better than Galileo's.
That's true.
Is there anything else going on in the night sky this month?
There's a couple of other interesting things. We have the summer solstice on the 21st of December.
Oh my goodness, I'm so Brit-brained today. I literally went to correct you and say winter solstice. It's not. My seasons are still flipped.
Yeah, like technically it's more correctly called the December solstice, so we don't have any of that confusion, but I'm stuck in my ways of calling it the summer solstice. So what that is as we come into summer, as Earth moves around the sun and the tilt of the sun, if you look at where is the sun at midday every day and measure the angle above the horizon, for the past few months, the sun has been getting higher and higher and higher above the horizon, and it reaches its maximum elevation above the horizon on the 21st of December, and then it starts to get lower and lower and lower again after that. So in some sense, you can think of it as the height. Astronomers usually think of it as the start of summer, astronomical summer as it's called.
Yeah.
But yeah, it's when we're getting the most sort of as face on as we can be to getting the sun's light. So
it's also most hours of daylight. This will be when Antarctica has its perma-day and no night, and then it's also when the Arctic will end up with no day, and it's midwinter so it's where the days and nights balance starts to shift as well.
Yes, that's right. And so if you're plotting that over the course of time, you see, as I was saying, the sun gets higher and higher up, and then it gets lower and lower and lower, and on this day it kind of stops and then turns around, and so that's where we get the word solstice from as well, because sol is the sun, and stis is stand still. Stasis. Yeah. So that's where we get the word solstice from. So that's on the 21st of December. There is also something very, very cool on the 14th of December, which is a meteor shower.
Is it the same one as last month?
No, a different one.
Oh, a new one.
No, this is the Geminids meteor shower.
Okay, so last month we had the Leonids. So that would mean that they originated in Leo. So the Geminids must be coming from Gemini.
That is correct. You nailed it. Now, it's interesting. The best time to see the Geminids meteor shower is actually before sunrise on Saturday, the 14th of December.
Okay, so Geminids is one for our early morning crew.
Early morning monsters, yes, that's right. Including myself now.
No.
Yeah, no, I feel
can't believe that you betrayed me like this.
And that's actually mostly because of the position of the moon. The moon's in a bit of an awkward spot this year, and it's getting close to Gemini as the shower starts to peak. So we need to wait for the moon to set to get the best view, but that's not going to set until 3 a.m, and so you need to wait until after that to see Gemini properly. And
just because the brightness of the moon will make it harder to see the meteors.
That's right. Yeah.
Okay.
And to look for them, you're looking sort of towards the northeast, again, in the constellation of Gemini. Just use your handy app, Stellarium, hold it up on your phone, and it'll show you where Gemini is. And you're just kind of looking, and, in ideal conditions, you might see a meteor every few minutes. That's sort of ideal conditions. Your conditions may change.
Now, like we spoke about last month again, even though that's where the shower sort of originates in the sky, that's where it looks like it's coming from, that doesn't mean that's the only place that you might spot a meteor, right? Like, you could see it going across the sky. It might appear in another spot, but that's like the highest concentration, the most likely place you're going to see one is in that part of the sky.
Yeah, that's right. And so we call it the radiant. It's where they seem to radiate from. So yeah, if you see one streaking across the sky sort of higher up or to the left or to the right, what you can do is you can trace that imaginary line back, and they all point to that same spot, Gemini. Unless, of course, you happen to see a random meteor from just a random other part of the sky, because they happen all the time.
Yeah.
Thousands of them every day. And so it's perfectly possible you might see one of those too, but they are just coincidental. They're not related to the Gemini.
It just so happens.
Just so happens, yeah.
If you're a nighttime person, not a morning person, and you are looking out at the night sky for hours, you might just see a meteor.
Yeah,
It might just happen.
It happens.
But it's not necessarily from that shower. But if you're out early morning, so morning of the 14th?
Yes, that's right.
So
Really
if
late.
I stayed up really, really late on the 13th, then I would see it the morning of the 14th.
That's right.
Okay, so if you get up on the 14th, you've missed it. Except you haven't, because it's the peak.
It's
so
the
you
peak,
still
that's
see it.
right.
But so
that's the best day. isn't it?
waking up really early in the morning on the 14th is the best day to see the Geminids, unless it's cloudy.
Yeah.
And then just, it's too bad.
I'm liking to think the proximity to the solstice means it's very unlikely to be cloudy.
Here.
Yeah, that's correct. Oh,
Yeah.
yeah, good point. Because, the Geminids is actually better visible in the Northern Hemisphere, but sucks to be them.
Sorry, Northern Hemisphere.
Now, the interesting thing about this meteor shower is that astronomers have traced where they call it the parent body, where are these bits of dust that make up the meteor shower, which object do they come from?
So it's like Halley's Comet
Causes the Orionids
The
in
Orionids.
October.
Yeah.
That's right. And that's the important point, in fact, that meteor showers are caused by debris coming off comets. However, this particular meteor shower, the debris has been traced back to an asteroid. Now, asteroids and comets you might think are the same thing. Like, they're just these big rocky objects that
Big
move
rocks
around
in
the solar
space.
system. Yeah, but no, comets have a lot more what are called volatiles, like frozen water, frozen nitrogen, things like that, whereas asteroids tend to be more solid material. There's a few different types, but but the hypothesis behind this is that this asteroid, which is called 3200 Phaethon,
Snappy.
yes, fantastic name. It's actually one of the closest asteroids to the sun. As in, when it's close to the sun, it's at one of the closest. Yeah. And so the idea is that it just kind of the surface gets baked, like how when you see out the desert and you see like the cracks in the landscape because it's so hot and dry, and then as the surface bakes and cracks, little bits can splinter off into space because it gets so close to the sun, and that's what we think causes the debris that makes this particular meteor shower.
Oh, that's pretty cool. So instead of it being a comet, which is just like spewing stuff off because it's really volatile, this is something that is a little bit more solid, but then like its space geography is basically what's making it crack.
Yeah, basically. Yeah.
Cool.
So that's all happening in December.
That's a lot.
Yeah, it's a busy month. It's a great month.
Busy, good month. And also, again, luckily here, summer, which means that we're less likely to have clouds covering it. So we might be missing the Milky Way, but there's plenty to make up for it.
Yeah.
But we haven't spoken about the constellation of the month.
The constellation of the month. No, that's right.
Constellation of the month.
Orion. Should I tell you?
Please tell me.
So the constellation of the month this month we've decided is Cetus.
Cetus, which is...
There's two interpretations. It's either Cetus the whale or Cetus the sea monster.
Now, I had a look into this because, you know me, obsessed with words and how that works. So, Cetus it comes from Latin, Cetea, which comes from the Greek ketos, so Ketos.
Okay.
Which means any huge sea monster is kind of what it meant. It's just big thing in the sea. That's Cetus.
Cetus.
Yeah.
Cetus.
So it's actually also where we think the term cetacean for whale came from. So the Latin family name for whales is...
I was just about to ask that.
Yeah. Because whales were just big sea monsters.
Yeah, look, if you're living in the days of ye old, then seeing a huge whale in the ocean is you wouldn't really know what to make of it.
Yeah.
It's a sea monster.
Big sea monster. Despite Cetus being called the whale, it looks less like a whale than Parvo, the bird.
Yes.
But yes, it is whale. Its name is whale, but it is more classically depicted as a sea monster. Where in the sky am I looking for Cetus, though?
Yes, good question. So we're looking basically exactly north, about it's not quite exactly above our heads, but we're facing north, and we're looking about 60 degrees up in the sky.
Okay. What time of night? Just after sunset?
Probably about 9 o'clock at night.
Okay.
Now it's a bit of a faint constellation, and it is a bit of a mess. It's kind of hard for me to give you a really obvious clues to look for.
Look like a whale. If you found the thing that looks like a whale, that's probably Pava.
Yes. Yeah, birds, whales, who knows? Maybe Pavo's a seagull. But yeah, you might have spotted a theme here where we're encouraging you all look it up on a computer first or something like that.
But quite often when you know what to look for, it is quite easy to spot in the sky.
Yes.
But it's just if you go out and are just trying to do dot to dots and you find a whale, it's probably not that one.
That's right. It does have a couple of bright stars in it, but they're kind of at opposite ends of it.
Okay.
And in the naming system of stars, they are called Alpha Cetae or Alpha Ceti and Beta Ceti. Interestingly, though, they've gotten the names mixed up because you know how we've spoken about in the past how the Alpha star is the brightest one and Beta, Gamma, Delta. Just by the way it turns out, Alpha Cetus is the second brightest star in Cetus.
And it's not the only constellation that happens in either. And I think that a lot of it is to do with how we define and measure brightness of stars.
That's right. And yeah, when the original names were laid down a few hundred years ago, the Bayer classification as it's called, they were still just judging it by eye. And so they didn't always get it right. Whereas modern technology can come in and go, that one we're collecting more energy from per second, and therefore it's brighter. And so Alpha Cetus is the second brightest star and Beta Cetus is the brightest star in that constellation.
But Alpha Cetus has another name. Or Alpha Ceti?
Cetae, yes. All of them.
Menkar.
Yes.
Which means nose.
There you go. It's the nose of the whale.
Although it is also called deneb-katos, which means the whale's tail.
Sure. So it's both ends.
Yeah.
It's the whale biting its tail.
It's not even that. It's just
yeah.
Well, because I think Menkar is one of the Arabic names. So
I think
in
you're right.
Arabic it's the nose, in Greek it was deneb-katos. There is another star in the night sky called Deneb, but that's in the tail of Cygnus.
Yes, it is.
So Deneb means tail, Katos means whale.
Tail
so
of the
deneb-katos is the whale's tail.
There you go.
Yeah.
That's really cool.
And then there's another star in Cetus, which is quite fun. It's not particularly bright. It's, I think it's Omicron.
Yeah, Omicron.
Yeah, Omicron Ceti.
Yep.
We're going to say it different ways each time.
I think we are, yeah.
But it's also called Mira, which means wonderful.
I remember reading about Mira a long time ago.
Yeah.
Is this the one is it like the pulsating star?
I just wrote down that it was in the neck and it meant wonderful because I thought that was quite nice. So I just went on names, not actual star stuff.
Yeah, from what I remember.
It was the first identified star of its type.
Yes.
But I don't know what type that was.
That's right. It is variable star. That's what it is. I'm remembering now. Yeah, it was the first star recognised that would get brighter and then dimmer and then brighter and then dimmer over a regular period of time. There were stars called nova, which would flare up once.
Right.
And then supernova, which would flare up and then disappear, which we now know to be related to exploding stars.
Yeah.
But then, it was the first example of what we now call a variable star, where brighter, dimmer on a regular pattern.
Yeah. But it means wonderful. I just thought that was quite nice.
Wonderful. But Beth, I'm aware that Cetus it's not just called a sea monster because they were bored. It's got some epic stories going on.
My goodness, this is literally I've written out a paragraph and I've underlined every other constellation that is involved in this story. So this is something that I love because it's one of the true examples of ancient Greek storytelling by the stars. Like the stars are a picture book. And I can just imagine people sitting outside, and it's something that I've done as well. It's like you're sitting outside looking at these pictures in the stars and using them to tell a story. Now, not all of these constellations are particularly obvious from the southern hemisphere. Again, this is all ancient Greek mythology, so it's a little bit easier to see from Greece.
Makes sense.
So, Cetus, the sea monster,
yes,
his story actually ends quite sadly.
Oh.
Because he was slain by Perseus. Underlined. Another constellation.
Is a constellation.
Yeah. To save the princess Andromeda.
Another constellation.
Who, maybe because she's a princess, wears a crown.
Oh, that's Corona Borealis?
Corona Borealis.
We spoke about that a couple of months ago.
Yeah. Constellation. from being sacrificed. So Perseus slew Cetus to save Andromeda in her crown from being sacrificed
Right.
by her father and mother, who were King Cepheus, also a constellation. Definitely won't see it from Perth, though. It's northern circumpolar.
Yep.
And Cassiopeia.
Another constellation.
Another constellation.
Oh, my goodness.
Yeah. Oh, doesn't stop there, because Perseus was not alone. He had his faithful companion with him, his loyal steed,
Yes.
Pegasus,
He rode in on a winged horse.
also a constellation.
My goodness.
Yeah. So we've got Perseus, Cetus, Andromeda, Andromeda's crown, Corona Borealis, Cepheus, Cassiopeia, and Pegasus. That is 7 constellations across the sky that you can use to tell this little story.
That's wonderful, isn't it?
It's so good.
And I mean, I think the takeaway for me for that is that's an example of some of the wonderful stories you can tell. There's nothing stopping anybody going outside tonight, inventing their own constellations,
Yeah.
and telling their own epic stories. Just like
Yeah,
that.
absolutely. I also wrote down, so that's a very Greek culture,
Yes.
but there are 2 groups of Amazonian peoples, so I'm probably going to butcher this pronunciation because I have absolutely no connection linguistically to Amazonian languages.
Right.
So the Tucano and Cobayua people, or Cabuea people, of the Amazonian rainforest, they use the same stars in Cetus, so a lot of those stars, but they see a jaguar representing their god of hurricanes and violent storms.
Wow.
Yeah.
I mean, but that topically makes sense.
Yeah, exactly.
Why would you see a sea monster when you live in a jungle?
Yeah, you're not going to see it. Whereas if you live on the Mediterranean and
Yeah.
you're a more seafaring people,
It makes perfect sense.
probably going to see something to do with the sea. But yeah, I love just going out and making stuff up in the stars as well. And the fact that these stories have survived for thousands of years across loads of different cultures as well, it just makes you get the space thing where you simultaneously feel really small but also really connected.
Yes. Yeah. What a great sentiment. Am I remembering correctly? You said Perseus slays Cetus. Does he trick it into looking at the head of the Medusa that he happens to have holding?
Yes.
Yeah.
Yes. So there's, again,
Many
with
stories.
thousands of year old stories, they go in all sorts of different directions.
Right.
But because the constellation Perseus is holding the head of Medusa, a lot of people say that he first showed the head of Medusa to Cetus, froze it, then went and did the same thing to Andromeda's parents, who were the ones that originally sacrificed her.
Yep.
But then there's some stories as well where he then just abandons her on the beach after their wedding.
That's right. Yes. I'd forgotten those.
Yeah.
So lots of different stories.
So many stories.
Ah, wonderful.
But I've got some more cool space stuff, not just story stuff, in Cetus. So, the snappily named galactic cluster JKCS041.
Oh, rolls off the tongue.
I know. It is in the constellation of Cetus. So, like we've described before, using the sky as a map, the area of that map that is labelled Cetus
Yes.
by the International Astronomical Union, which I need to say very carefully because otherwise it just...
Yeah, it all blurs together. Yep.
It is the most distant yet discovered galactic cluster from us
Is
on
that
Earth.
right?
Yeah, it is 10.2 billion light years away.
Oh, nice.
Yeah.
Just a cheeky 10.2 billion.
Just cheeky 10.2 billion. But basically, because of where Cetus is in the night sky, so we were just saying that in the sky tonight, if you go out, the Milky Way is basically on the south.
Yeah,
We're
it's very
looking
low.
south.
It's like on
It's
the
very
horizon,
low.
yeah.
Whereas Cetus is in the north, but also quite
High up.
high up.
Yep.
So because of where Cetus is, it's basically perpendicular to the galaxy, which means that there are lots of other galaxies visible in Cetus.
Yes. Yeah, we're not looking through the Milky Way. We're not getting obstructed by our own galaxy.
Yeah. So when you're trying to look for other galaxies outside of our own, the Milky Way gets in the way, just because of all the stars, all the gas, everything that's there going on because it's so close to us. So Cetus being basically nearly a right angle to the Milky Way in the sky means that we can see a lot of cool stuff out there. And the brightest is Messier 77. which I don't know anything in particularly interesting about, but there's a nice bright one. And there's also a nebula called the Pac-Man Nebula because it looks like Pac-Man.
Oh, I have heard of Pac-Man Nebula. Yes, it kind of does. Yeah, it's a cloud of gas that just coincidentally, from our angle of viewing, looks like
Pac-Man.
Looks like Pac-Man.
So lots and lots of deep sky stuff in Cetus. Again, they're not going to be naked eye visible, but I just like knowing they're there.
Yeah. Well, I'm imagining that you've just finished looking at Jupiter with your small to moderate telescope.
Oh yeah.
You might then turn to look at what you can find in Cetus.
In Cetus.
There you go. Wow, thanks for that, Beth. That was a fantastic constellation of the month.
You're very welcome. Thank you.
But I want to move on because I mentioned in last month's podcast that we had an engineer visiting the Scitech planetarium.
Yeah.
And
so the planetarium was closed.
Yeah, planetarium was closed for a couple of days while they did some upgrades and Scitech had some electrical work done. You were out on a bit of an adventure.
So, Leon is elbow deep in the planetarium. I am at Curtin University with the rest of the Scitech team. A lot of us went over and we went to visit the Earth and Planetary Science department because they do lots of cool stuff to do with space.
They do, and I'm very jealous.
Yes, I'm pretty sure that one of the messages that I sent during our visit was I got to hold some of Mars.
Yes.
Yes, and I also saw a bit of Bennu.
You saw a bit of Bennu.
Yes.
Wow.
Yes, it's very exciting. So,
should we go through those in order first? You held a bit of Mars.
Yes. So the bit of Mars was a meteor. So a little bit of Mars that has somehow made it to the surface of planet Earth.
In that case, it would be a meteorite.
A meteorite. My apologies. It was a meteor.
It was a meteor,
and then was a meteorite.
Yes.
So I got to hold a bit of Mars. I didn't touch it because that degrades the sample, but I held the sample container.
Oh, I was going to say, is it in like a resin or something to keep your grubby mitts off it?
Yeah, but my mitts were perfectly clean, thank you. I was wearing gloves. But yes, so I held a preserved sample of a Martian meteorite.
Wow.
Because part of the problem in space is that it's very, very difficult to get samples back from Mars.
It is, yes.
Yeah, we haven't done it yet successfully.
No.
And relatively recently, we did manage to get samples from a meteorite. No, an asteroid. Oh my goodness, all these space words mixing up in my head.
Yes.
So we did manage to get a sample from an asteroid. OSIRIS-REx went up and its mission was to bring back samples from the asteroid Bennu.
Right.
Now, if we're talking about this month and birds in the night sky, Bennu is actually a bird as well.
Oh, I didn't know that.
Ancient Egyptian.
It is too. Yeah, that's right. I've
so many birds going on in December.
So NASA sent the OSIRIS-REx spacecraft to the asteroid Bennu.
Yes.
To collect samples and then bring them back.
Yes. And I got to see a bit of that sample.
Wow.
Now, when I say a bit, I mean I saw some black dust.
Yeah, like a couple of milligrams or something like that.
Yeah, tiny, tiny amounts. But I saw it. It was cool.
Yeah, I remember when that got back because it collected way more material than they were expecting to.
Yeah, absolutely. Which is awesome for research because especially when you're trying to work out like composition of samples. Often in order to do that most accurately, you end up destroying the sample.
Yes.
So the more that you can get, the better, because it means that we can preserve some and study it visually or study it using non-destructive means.
Yep.
But if we've got enough that we can also do destructive testing on it, destructive testing can tell us so much about those samples. Absolutely.
And yeah, knowing what Bennu is made of is a really interesting question because Bennu is... It occasionally gets close-ish to Earth.
Yeah.
It's about 500 metres across, so it's not a small asteroid.
No.
It's not the biggest one out there by any means, but 500 metres across, if that hits the Earth, that's going to do a lot of damage.
Yeah,
And so that people want to understand, what's it made of, what's the feasibility of asteroid deflection methods that we could use.
Well, there's also, in a sort of capitalist nightmare sense, can we mine them?
Can you get resources out of it?
Yeah, because there are asteroids that we found out there which contain more gold than has ever been mined on planet Earth. We think.
Yeah.
But
yeah,
if we
you've
can
gotta
actually tell
get
by
some
bringing
samples.
back parts of these asteroids, and also part of what makes it exciting is it means that we had a space mission which went up, collected samples from something and came back, which means that we can maybe use some of that theory of having a lander that has taken back off again. We can extrapolate some of that learning to maybe one day bringing back samples from Mars
Yes,
and
that's
learning a
right.
bit more about the surface of Mars.
Yeah.
Because there's only so much testing that you can do on a Martian surface. And this
On
is
a
something...
Martian meteorite, do you mean?
No, on the Martian surface. Like, there's only so much we can
that
learn
the
from
rover can do.
that
Yeah,
a rover
gotcha.
can
Yeah,
do
right.
because it doesn't have
Whatever
massive
equipment we have
laser
on it.
machines that take up several corridors of basement,
Yep.
like they have at Curtin. So there is actually a project that Curtin's trying to get off the ground as well called Life Springs, where what they want to do is send a craft to Mars and then bring stuff.
Bring stuff back. Yeah,
Yes. Which means that you've got to have, like, they're trying to minimize launch by doing one launch, but having two
right. Oh, two, I guess,
space.
objects.
Yeah, well, maybe even more. So having a surface object, and meanwhile another object is launched at the same time that ends up in orbit around Mars, which can then pick up something from a lander
gotcha.
and then bring it back to Earth.
Yep.
Because they've seen some really cool stuff. So linking back to Western Australia as well, the oldest fossils that we've ever found on planet Earth were stromatolite fossils.
Yes.
So stromatolites are microscopic living organisms, and they were found, the oldest sample, in the Pilbara.
Wow.
Yeah. And one of the team that found them is the current head of Earth and Planetary Sciences at Curtin.
So I think they're perfectly placed, I would say.
Yes. So there's been lots of theories about how life on Earth originated, and a relatively new, in the scheme of research, theory that's come out is there was... Previously, we thought life came from the oceans, but now there's a theory that maybe instead life came from hot springs. Now, we have potentially found evidence of hot springs, ancient hot springs, on Mars.
Yes.
Now,
Right.
if life on Earth maybe originated from hot springs here on Earth,
I see where this is going.
did they maybe originate on Mars? Can we take a little sample and bring it back so that we can have a little look at it?
Right. I see the bigger picture now.
Yes,
Yep.
yes. So that was the thing that really stuck with me, maybe because, again, my background in microbiology that's the bit that I really latched onto, like, because, several professors at the university I went to were looking at how life on Earth originated, and, even odd stuff like panspermia, which is the theory that life on Earth
came from
originated
space.
somewhere else, came from space. Did it come from Mars?
Yeah.
What if the stromatolites on Mars, if they are stromatolites, if they're old, maybe did we come from Are we Martians, Leon?
Martians? Oh,
We
deep.
don't. So yeah, some
Deep,
super, super exciting stuff coming out of Curtin.
That's
And
really
hopefully, maybe one day we'll get someone from Curtin to actually talk to us about it.
Ooh, all right.
They're
We'll-
pretty keen, and
we'll
we're
get
pretty
onto
keen.
that.
So
All right.
we'll get onto that. So don't worry.
That's cool. That does bring two things to mind, just that you've mentioned there, where you spoke about destructive testing of samples and things like that. Yeah, one of the things that's interesting is that there are still, to this day, unstudied moon rocks that were brought back from the 1960s and 70s
Yeah.
for that reason. And NASA put them into storage for 50 years because they just knew that technology 50 years after the moon landing would be an order of magnitude better than it was back then. And so now there are moon rock samples being opened today to be studied with more modern technology. And then, I imagine some more of them will still be stored away for another 50 to 100 years.
Yeah.
Same goes with samples from Mars, if we did a sample return. And then speaking of NASA, NASA is halfway through doing a sample return mission on Mars. But it's kind of, so you got the Perseverance rover on Mars, which extract rock samples, and how they get them back has always just been swept under the rug of like, in 10 years time we'll build another spacecraft, it'll go collect those rocks and it'll bring them back to Earth. But now they're really stalling on that because they haven't really thought through how to do that.
Yeah, it's like that's that sort of planning ahead where you put some in storage so that maybe in 50 years technology will advance, and it's like, well, let's collect the rocks and then hopefully in 10 years time we'll have worked out how to get them back.
Yeah.
And we still haven't quite worked it
it's not
out
quite-
yet.
yeah,
But
we'll get there.
Yeah, so there's some really exciting research going there at the moment. We also went to see our wonderful friends at Binar.
Yes, our friends.
Yeah, so Binar are a cube satellite program,
Yes,
I guess.
that's right.
And they're very, very small, which is great fun.
So yes, the CubeSats that Binar builds, the group builds, are 10 centimetres on a side, so it's a little cube that's 10 centimetres on each side.
Yeah.
And yes, in 2021 they launched Binar 1, the first Western Australian built satellite, and then earlier this year up went Binars 2, 3 and 4.
Yeah.
And then they only just recently returned to Earth, burnt up in the atmosphere.
Yeah.
As Binars.
Yeah, so they're currently going through data that they've gotten from those satellites and using it to develop the next generation of Binars. And also, the satellites are designed to burn up completely in the atmosphere, which means we don't get space waste.
Junk,
No space junk from the Binar. So good job, Binar.
And Binar, if you haven't picked up yet, is the Noongar word for fireball.
Oh, I genuinely didn't know that.
Ah, there you go. So when it burns up, it becomes a Binar.
Oh, that's rather
quite
lovely.
nice.
It's very poetic. But yeah,
Wow.
we saw so much stuff in such a short period of time. There is definitely stuff that I have missed out and not said. We got the opportunity to go into Curtin's visualization suite and see some awesome stuff there as well, including some awesome maps of the surface of Mars to do with topography and meteorite tracking, and awesome. But yeah, also quite a lot of the stuff we saw completely went over my head because it's just so
it's a research centre. Yeah,
it's a research centre. They are dealing with the cutting edge. These are absolute experts in their fields. They know so much about what they're talking about, and I am a nerd, but not anywhere near as expert as they are in their specific fields.
It's all right. That's why expertise is a thing.
Exactly. But it was also all very, very exciting, and I'm really looking forward to being able to, just see what comes out in the next few years, because it sounds like there's some really exciting research going on and people who really, really care about what they're doing, and also the future of astronomy and space research in Western Australia.
Yes, there's a lot of exciting stuff going on.
I think it's time for Space Photo of the Month.
Space Photo of the Month.
Space Photo of the Month. My space photo is a bit weird.
Okay. What we're looking at is a mostly dark screen. There's a white horizontal line that divides the picture in half. So it's two
pictures.
Two pictures of the same thing. And I happen to see the title. It's called Night Sky Comparison. So it looks like there is a number of stars. I can make out individual inputs, but I can also see like a cloudish smudge, sort of like you might see if you're looking at the Milky Way. And the top image and the bottom image are the same. They're the same image, or the same picture. However, the top image, I can see more individual stars. So it's almost like if you're outside looking at the Milky Way, and then someone shines a torch in your eye, and then the bottom image is what you see for the next 30 seconds. You can't see quite as much detail. That's basically what we're looking at here. What have we got here, Beth?
So, this is a comparison between the night sky in the original release of the film Titanic and the updated release of the film Titanic. There is a film coming out this month. You may have heard of it. It's called Moana 2. And there is apparently something in it about navigating by the stars, something very, very important to Polynesian cultures. And I was just thinking about, I was thinking about that because my partner loves Moana, and I was thinking about navigating by the stars, and then I was thinking about stars in film, and then I remembered that when the original Titanic film came out, astronomer / science communicator Neil deGrasse Tyson had a problem with the stars because the stars in the Titanic sinking scene in Titanic are not accurate to how they would be in 1912.
Yeah, right.
And James Cameron is well known for his attention to detail. For example, the shots of the sunk Titanic
were real.
Actually taken by James Cameron, who went to the Titanic to do so. And Neil deGrasse Tyson pointed out that the stars would have been wrong for where they were in the world. And so on the re-release, they updated the stars. So the second image are the correct stars that you would actually have seen, rather than just random night sky.
Yeah. The graphics artist has just slapped a star field on there.
Yeah.
No, it's the correct stars.
These are the correct stars.
And that also explains, which I didn't really clarify, even though I can see more stars in the top image than I can in the bottom, they're in different spots. So it's clearly a different part of the sky.
Yeah. But that's also partly like that first image. Can you see more stars because a graphics artist just went Starbrush and just like spattered stars all over the sky?
Yeah.
Who knows? But yes, so the second picture is actually an accurate night sky. So I was just thinking, have a look in your favourite films. If you spot any constellations that you've heard of, and if you spot, Tucanus in the northern hemisphere, well,
it's a very niche reference, but
it is a very
someone's
niche
spot
reference.
it.
Someone is going to spot it. But yeah, I just thought that was good fun, especially with a film coming out this month that uses a lot of navigation by stars.
Yeah, very cool.
So yeah, that's my space photo of the month for you.
Thanks for sharing, Beth. I will share you my photo now.
Oh, here we go.
There it is.
I have
Gotcha.
a before, I have an after. Now, the both before and after pictures have a big red arrow on them. The before picture, we have what looks like quite lush forest with a road leading down to what looks like a big dish that has been sunk in the ground. There are 3 towers around the dish. Suspended between these towers is some sort of structure with what looks like scaffolding, but it's not. It's like permanent scaffolding. That's the shape that it's making rather than the actual material. Sort of a steel lattice, I would imagine, with sort of a small white dome hanging down from it a little bit. That's the before. The after is same place, I would guess, from a slightly different angle, except I can only see 2 of the towers. There is no longer something suspended between them. The lattice is on the ground. The dome is also on the ground and cracked, and the dish that is in the ground is no longer a lovely white, but is grey, has some of the forest breaking into it, and also it looks like the disc has like been dropped basically, and shattered in some places. What's going on?
Yes, excellent question, Beth. So what we're looking at here, and this actually almost sort of becomes its own space fail of the month.
Oh no!
But it's actually not this month. But there's been some really interesting news released about this object this month. So this is the Arecibo telescope, which is or was, I should say, a radio telescope in Puerto Rico. So way over there, and yes, for a very long time, when it was built in the 60s up until the mid 2015, 2016, it was the largest single telescope in the world. It's 300 meters from side to side.
Whoa!
And
is that bigger than the Very Large Telescope?
Yes, but different wavelengths. So
is that bigger than the Extremely Large Telescope?
It is, yes, but those aren't really fair comparisons to make because they're different types of telescopes.
I just love bringing up the Very and Extremely Large Telescopes whenever possible because I think they're silly.
Yeah, and yeah, of course, great names. But yeah, Arecibo. So it's so big, you couldn't fit it on an actual sort of single structure. It's actually built into the sunken cavity of a volcano.
Oh wow!
So it's just following the natural curvature of the mountain, and those towers you're talking about, they suspend. Because when the light bounces off that dish, it needs to focus, and they couldn't build a focus that big either, so they had to suspend the focus above the dish, and it's held there by these by these cables and this scaffolding and this dome structure is where the focus lies. Now,
when you say "it's," the contraction "it's" normally means "it is." I'm guessing in this case it means "it was."
Yes, sorry, it was. I keep talking about it in the present tense. But yes, unfortunately, in the year 2020, in December, the cables ripped out of the tower, and the whole thing came crashing down. And it's been decommissioned now, so they're not going to repair it. But that's what the after photo is showing. It's showing the result of that dome come crashing down into the dish, and the cables, as they've whiplashed, they've ripped big gashes into the dish as well.
Oh, that's from the cables.
Yeah, and so
they do like line up with where the towers would be.
Yes, that's right. And the greenery, you can see, was actually there the whole time. It was just underneath the dish, and it's now been exposed. And now this might date me particularly, but if anyone's seen the movie GoldenEye, and at the end of the movie, and they track it down to Trevelyan's lair, in the movie they filmed that at Arecibo. So go back and watch it, and then look at this picture, which we'll post on Instagram at Particle WA, and you'll see. And in the movie GoldenEye, the whole thing actually gets destroyed, and it's kind of funny that just a couple of decades later it did come crashing down. It actually happened.
Yes. Oh my goodness.
But the reason I've made this the picture of the month, and also I guess the space fail of the month, is that the final report on why it collapsed has just been released.
Oh.
And it turns out it was really surprising that the cables didn't snap; they actually ripped out of their socket. And
so it's like tension in the socket wasn't high enough anymore.
Yeah, and it was really unusual because this particular socket design, the way they do it is they feed the cable into a cavity, and then they pour molten nickel into it.
Oh.
And then as the nickel hardens, it sort of becomes one with the cable.
Right.
And then it becomes this big plug.
Yeah.
And this sort of design is all around the world, and the study that's just been released has said there's not been a single recorded failure of this type of attachment in history of their use.
Oh.
And so they've been trying to rack their brains why in Arecibo did it collapse.
Yeah, because if that's the only known failure, that means
what's going on?
Something weird has happened. But also, where else has this technique been used so that we can make sure that
quite a lot
they
of places,
don't?
apparently.
I imagine like cable bridges as well is probably
things
quite
like
a common place to use that sort of technique.
Yeah, pretty much. And now I'd be lying if I said I was an expert in it, but I'm quoting the paper that said, they've checked and it hasn't happened. And here's what they think has happened.
Okay. So
I said this is a radio telescope, so it collects radio waves from space, but it's also a special type of telescope, also called a radar telescope.
Okay.
So radio telescopes is you wait for the radio waves to come to you. That's what you do. Radar telescopes is you beam them out yourself and then you listen for the echo to come back. And it's really great for spotting nearby objects, like, for example, asteroids that are close to Earth. And so Arecibo is well known for studying in detail getting some of these images of asteroids that come close to Earth, including Phaethon, from which the Geminids meteors come from.
Wow.
And so, just coincidentally, as the Geminids come in December, we get the release of the report on why Arecibo collapsed. And what they think happened is to get these, think about this. You're sending a radar signal from the ground, from Earth, out into space, and then it has to bounce off something and then come back again. You need an incredibly powerful signal. And they think that the radio waves that they were emitting may have stimulated little electric currents down the wires that are holding up the telescope.
So they basically think that we rattled the wires.
Yeah, they electronically rattled the wires so much that the nickel started to, they call it creep, and just, a couple of atoms at a time, it just deforms and deforms and deforms.
But over
decades.
50 years. Yeah.
So as I said, it wasn't the cables that snapped, but they ripped out of the socket because the nickel had deformed.
So that's not likely to be a replicated issue in something like a bridge.
No, that's right, unless you're broadcasting massively powerful radio waves from the middle of the bridge, which is what this thing was doing. Arecibo's been used to actually beam messages from Earth to other stars and globular clusters because it's so powerful. And this unintended side effect of that, they think this is they've ruled out everything else.
The hypothesis.
They haven't really proved that this is exactly what happened. They've just kind of ruled out every other idea. Is that it stimulated these little electric currents that over time deformed the nickel.
That's amazing. That's ridiculous and amazing and so cool.
Yes.
And also very sad.
The sad news is that the National Science Foundation, which is the United States federal science agency, has decided they're not going to rebuild it. Yeah. Which does lead us nicely onto a new section called $1 billion.
$1 billion?
$1 million.
This new segment, we're just going to pluck an example out. What will $1 billion get you in space? And in this case, how many Arecibo telescopes do you think you could rebuild for $1 billion, Beth?
It's the biggest one, right?
Yeah, it was. There's a bigger one in China, but we can still talk about Arecibo, though.
I think that you would be able to make 4.
4 is a good guess. You'd be able to make 2. So it's estimated that to rebuild Arecibo from the ground up, with modern technology, because you can see there it's so badly damaged, there's no point in fixing it. You just demolish it to start again. Yeah, would cost almost $500 million, and that's just a step too far for the National Science Foundation.
Yeah, that's so for $1 billion, you could purchase 2 brand new Arecibo telescopes.
That's right. And it goes to show that the cost of telescopes scales exponentially with the size. Twice as big doesn't mean twice as much. It means almost 10 times as much. And so if you're trying to build a telescope that's 300 metres across, the costs are literally astronomical.
Hey. Oh, thank you, Leon. I very much enjoy $1 billion.
$1 million.
Hopefully we'll see that segment come back so we can get our heads around just how expensive or surprisingly cheap some things in space can be.
Yeah, the price is very hard to estimate because there's so many strange variables that you don't normally think about.
Yeah. Oh, awesome. Well, thank you so much for having me, Leon.
Yeah.
This has been our last podcast of the year.
It is our last podcast of the year. Oh, damn.
Well, I mean, we're probably going to record the next one in December.
So we'll record the January one. So I guess we'll have to thanks everybody for listening to all of our podcasts this year, and especially this particular episode as well.
Yeah, I think we wish you Merry Stargazing.
Merry Stargazing.
And a Happy New Year.
I forgot to mention when we were talking earlier about important dates during December. There is, of course, the 25th of December, where we celebrate the birthday of one of the most influential historical figures.
Yeah, super important. I can't think of anyone who's influenced history more in some ways.
Yeah, so happy birthday to Isaac Newton.
Yeah, Sir Isaac Newton.
Sir Isaac Newton, yes.
Yeah.
And thanks for listening, everybody. We'll see you in the January 2025 Please Look Up podcast. Until next time, it's been a time and a half. Beth, thanks for being here.
Thank you for having me.
And thanks for listening. We'll see you next time. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.
Yes.
And
Michael.
Michael, no emails during recording.